Welcome students. Myself Professor Sunita Khanna. In control system, we will learn today what is the root locus technique. The content are introduction, importance of root locus, angle and magnitude condition, rules to construct the root locus, example on each rule. Introduction. What is root locus? Root locus is a graphical representation of the closed loop poles as a system parameter is varied. It can be used to describe qualitatively the performance of a system as various parameters are changed. It gives graphic representation of a system's transient response and also stability. We know transient response of the system. We also learn various time domain specifications. We can see the range of stability, instability, and the condition that cause a system to break into oscillation. Now we will see what is the angle and magnitude condition. There are two important conditions that we need to know to obtain the root locus with the characteristic equation. The characteristic equation in general is 1 plus g of s h of s is equal to 0. That means g of s h of s is equal to minus 1. As the s plane is a complex, we can write this minus 1 as minus 1 plus j0. This equation has magnitude as well as phase. So modulus of g of s h of s is equal to modulus of minus 1 plus j0 and that is 1. So it is same for positive as well as negative feedback system. And what is the angle condition? Angle g of s h of s is equal to plus minus 180 degree. But since minus 1 plus j0 point can be traced with angle equal to plus minus 180 plus minus 540 plus minus 900, that means which are the multiples of 180. We can thus have generalized angle condition as angle g of s h of s is equal to plus minus 2q plus 1 into 180 degree, where q equal to 0, 1, 2, 3 and so on. Every point on the root locus will necessarily satisfy the magnitude condition as well as angle condition. What is purpose of angle condition? It is to calculate whether the given point lies on the root locus or not. And what is the purpose of magnitude condition? It is to calculate whether gain at any point which is on the root locus. So we will take one example and we will find whether that point lies on the root locus. So I will take one blackboard. So this is the open board and I am sharing. So we will take another example and suppose our example is like that g of s equal to k upon s plus 4, k upon s plus 4, which is unity feedback system, means what? H of s is equal to minus 1. So this system is given and we have to check whether the point which is at s is equal to minus 2 plus 4j, whether this point is on the part of the root locus or not. So what we will do? We will find the angle condition. So we know angle condition, angle of g of s is equal to what will be here, and we will find this angle at s is equal to minus 2 plus 4j. So we will put value of s here and it becomes k upon s, that means minus 2 plus 4j. Okay, this s and into bracket s plus 4. So minus 2 plus 4, it will be plus 2 and it will be plus 2 4j. Okay, now we have to find the angle. So how we will find the angle? Angle will be k plus 0 because there is no any imaginary part, only real part is k. Then we will find angle of this first term, it is minus 2 plus 4j, and into angle of the second term, it is 2 plus 4j. And when you will find that angle, then this is rectangular form and its polar form, the angle is 116.56. 116.56. While this k plus 0, it will have 0 angle. So this, and as angles are added, it is plus the angle of this 2 plus 4j, it is 63.43. 63.43. And when you add this, it will become 0 degree upon 180 is equal to minus 180 degree. And hence, as it is multiple of 180 degree, we can say that this point lies on the root locus. We will go to our slide. So again, this share the screen, new share, and this side will be our example. So I think it is visible to you. See, what is that example? Determine the gain k. In last example, we decide whether the point lies on the root locus or not using angle condition. Now using magnitude condition and angle condition, we will see the system gain k at this point minus 3 plus j3. And this is the transfer function k upon s plus 6 into s. So g of s, h of s at this point will be k upon place the value of s. Okay. So it is k into 0 degree or 360 degree. It is same. And this is the angle. So what it becomes? K angle 360 degree divided by 18 angle 180 degree. So angle of g of s, h of s is equal to 180. So 360 minus 180. It is 180 degree. That is equal to 1 into 180 degree. Here 1 is an odd multiple. So minus 3 plus j3 lies on the root locus. How to find k? Magnitude is equal to mod of g of s, h of s is equal to 1. So k upon 18 equal to 1. 18 is this value. K upon 18 equal to 1. So what will be k? K has value 8. When we will construct the root locus, these are some rules. First property is that symmetrical about real axis. That means root local is always symmetrical about the real, that means x axis. Rule number 2 is number of root locus branches is equal to number of open loop poles and open loop zeros. And rule number 3 is real axis loci. What is that real axis loci? A point on real axis lies on the root locus if the sum of poles and zeros to the right hand side of that point must be odd number. Okay. So again, for that purpose, we will take one example, and by that example, we will solve whether the root locus real part is lying on the root locus or not. Okay, so what is starting and ending point? The root locus starts at open loop pole with k equal to 0. And it terminates at open loop 0 where k has value infinity. And so see this, these are the poles and these are the zeros. We indicate poles by cross and zeros by 0. So these are the starting points and these are the ending points. We will go to rule number 4. So that is angle of asymptote. How you will find angle of asymptote? The angle of asymptote phi a is given by this rule. So it is a root locus branches which terminates at infinity. So number of asymptote equal to p minus z. The angle of asymptote gives us the direction along which these p minus z branches approaches infinity. Okay. So angle of asymptote, we will again take one example to find the angle of asymptote. And for that purpose, I will take one page, and this is the new page. So share. So this is a new page, and we will find what is the angle of asymptote for the function. And before that, we will see rule number 3, where the real axis root locus lies. Okay. Suppose our g of s, it is given as k into s plus 6 divided by, this is k, s plus 6 divided by s into s plus 2 into s plus 6. Okay, we'll take s plus 5. Again, it is unity feedback system, means what? H of s is equal to 1. So we have to find real axis loci. Rule number 3. So what is real axis loci? The number of poles, addition of number of poles and zeros to the right side of that point should be odd. So this is S plane. this is S plane. And what is its real axis? Sigma. Imaginary axis j omega. Well, how many poles are there? S equal to 0. So this is one pole. Suppose this is -2, -4, -6. -4, -6. So S is equal to -2. This is one pole. S is equal to -5. So this is -5. This is one pole. How many zeros are there? 0 is only at S is equal to -6. So this is 0. Now see the part between -2 and 0. Okay, so this is origin 0. And when we will see the number of poles and zeros to the right side of this -2, it is 1 only. And hence this red portion indicates that it is a real axis loci. But when you will consider this pole at S is equal to -5, to the right side of this -5, there is, we will see the remaining part in next lecture. काय रे बेटा?
थँक्यू मॅडम. मी आता फोन होता.